Okay. So that is our formula. And now we have to calculate that. We have to figure out what PMT is. Okay, let's do that. So it's just like before, right? So it's just like before. We have our formula, right? And we have to solve for PMT. So again, it's just like before. What we're going to do is you want to work with the innermost parentheses first and work your way outward. I mean, you could do this division down here as well first. That's what we're doing. Right? So we handle the numerator and denominator separately using order of operations. I mean, the denominator is easy. You just simply divide. For the numerator, you have a lot more going on. So we're going to work with the innermost first, parentheses. We get this. And then we get 1.005. And that's being raised to, what's that, 360, 12 times 30? That's where this comes from. I know I didn't show that step, so should have showed it. Maybe what I'll do after this is I'll add that step, then I'll email the notes. We subtract 1, and we get this. As you can see. So together, we get this here. So we want PMT, that's our unknown. It's just like before, right? Essentially, we're going to solve for it. So you could divide first, which is what I'm doing. You know, do this quotient, then divide like so. And we get PMT is this. So we get PMT is this. Okay, so again, this is what we got here, right? We divide. This is what we get from this quotient. Okay, then we divide by this here. Like so. And we got our PMT. So our monthly deposit is $796, and it looks like rounding 40 cents. That's our monthly deposit, or our monthly payment, I guess. Well, monthly deposit because we're putting into a retirement account. Okay, that's what we have here. Okay, then the rest is just like before. So the rest is just like before, right? We want to know the second part B. Part B asked how much we're putting in total. Right? See if I can get to it. Part B, Part B asks how much are we putting in total. So if we're doing that deposit each month for 30 years, right? They're asking how much are we going to end up putting in? Well, this is per month. So we have this per month. All right, well, to get it into years, we multiply by 12, right? So we have 12 months per year. Then this is for 30 years, so we multiply by 30 as well, and we get this. So that's how much we end up putting in after 30 years. So through our deposits, over the course of 30 years, we end up putting in $286,704. And remember, the money in there is earning interest. Well, how much interest do we end up earning? Well, we know there's going to be $800,000, right, after 30 years. Okay, but let's subtract off how much we put in. Because if we subtract that off, whatever's left over came from interest. And that's what I'm doing here. And we get this. So this is the interest. We're subtracting off how much we contributed. The interest is what's left over. All right. Are there any questions about this one? Okay, so this one's a little bit different, this next example. Actually, and again, these come from the textbook. That's where I have over here. In the other examples too. So here this is different because here we're considering withdrawing $1,500 per month each month for 25 years. So now basically we're saying, okay, now we retire, okay? And we want to be able to take out this much each month, $1,500 each month. And this is for 25 years. And let's say we know the account is earning 6% interest. The question is, how much do we need in our account in the beginning for this to happen? You know, how much do we need to have in our account? Well, here we have a payout annuity. And why is that? Because we're doing many withdrawals, right? We're withdrawing each month for 25 years. So there's multiple withdrawals happening. And because of that, we have what's called a payout annuity. And when you have that, remember, okay, this is the formula you use. It's a little bit different, as you can see. So this is what happens here. Okay. You know, P sub 0, that's the balance at the beginning of this. That's the balance in the account at the beginning. So if we want to know how much we need to have in our retirement account to be able to withdraw, P0 is what we're looking for. And also we're assuming, you know, I've said this before, unless stated otherwise, it's compounded, the account will be compounded as often, okay, as we take withdrawals. So the account is compounded as often as we withdraw money. So for the first example here, right, this is the same problem. P0 is what we're looking for. That's the amount in the account. PMT is we know we're taking out $1,500 each month, right? So PMT is what is $1,500. Our interest, right? We have to convert it to a decimal. And this is going on for, or excuse me, N is how often it's compounded each year. But unless it's stated otherwise, right, it's compounded as often as we take out money, as we withdraw money. And we're withdrawing monthly. So it's compounded monthly. So in a year, it's compounded 12 times. And the number of years we take withdrawals, that is the number of years this is happening for, that's the 25 years. So we put that into the formula and we calculate, as you can see. And now we just do the calculation as before. So again, you want to work with numerator and denominator separately. In the denominator, you just divide. That's what we're doing. In the numerator, we have a bunch of parentheses, right? So let's use order of operations. So we have this. So we do the innermost one first. We get this. And we're raising it to the negative 300. And this was the same as over here, as you can see. So, you know, here we have to use a calculator, of course. We end up getting this. When we do 1 minus this. And then to get P0, we carry out this quotient, and we get this. So the balance has to, so we need to have in our account $232,810.30. We need to have that in the account in the beginning. That's what our P0 is. Okay? All right, so I think I'm gonna have to stop here. So I'm gonna stop recording.